Hi folks, you see this is the problem we have come across, and this problem is the maybe solved with the transportation. It may be called as a transportation problem, and we will be solving with the Hungarian method. Okay, we will solve with the Hungarian method. So first, how do we solve it? In the assignment problem, we need to see that how many workers are there for different tasks. So we see we have the 4 operators, okay, and 4 workers, and we have 3 tasks. So you know that in the transportation problem, we can work only on the balanced one. It needs to be balanced so that we can find the a proper assignment. Plus, we always minimize. Since it is a minimized problem, so we don't have to be worried about it. Is a minimization problem. We have to minimize the total cost or the time. You may say these are the time. The worker 1 is taking 19 minutes for completing the task 1. The worker 1 is taking 36 minutes to complete the task 2. The worker 1 is taking 25 minutes to complete the task 3. Likewise others. So let's make it balanced first. T1, T2, T3, and T4. Since we are introducing the dummy one, so we will be just using 0 for every element. Okay, the rest would be the same. 19, 36, 25, 23, 37, 16, 45, 30, 25, 28, 40, 30. Okay. So you see this matrix is ready and it is balanced. So we can solve with the Hungarian method and we can assign the jobs to the different workers, to worker 1, worker 2, worker 3, worker 4. Okay, so let's move ahead. First, we need to do what we do to find the assignment to the proper worker. The least time taking worker is to reduce the row. So how do we reduce the row? Find the least one in the row. So whatever in every row, we will find the 0. So there is no need of this operation over here. Why? Because you see every time we will go for that, we would get the 0. So 0 would be the least in this row, 0 would be in this row, 0 would be in this row, 0 would be in this row. So there is no need for row reduction. The column reduction is required, and for that what we do, we will go with finding the least in the column. 19, 23, 45, 28. 19 is the least. You see 19 is the least. 36, 37, 30, 40. So 30 is the least. 25, 16, 25, 30. 16 is the least. 16 is the least. And 0. You see 0 is the least one over there. Now we have to reduce the column with these numbers. So what we will get, 19 would be 0, 23 would be 4, 45 would be 45 would be 45 would be 26, and it would be 9. Okay, if we reduce this column with the 30, 36 would be 6, 7, 0, 10. 25 would be 9. 25 would be 9, 0, 9, 14, and that would be the same, 0, 0, 0, 0. So you see, this is the matrix we have got it after row and column reduction. Row and column reduction. So let's assign with the same formula. How many zeros do we have in the first row? 2. We will not assign. How many zeros do we have in this row? 2. 2. We will not assign. Row 3. 2. Row 4. 1. We will assign. Okay, when we will assign, the whole column would be cut. Now we have to see in the first column how many zeros are there. 1 0 is there, so the whole row would be cut. In the next, how many zeros do we have? 1. We will cut the row. In the next column, we will see how many zeros do we have? 1. So we will assign this and we'll cut this. So you see, this is our solution. How come? Because we are able to assign all of the 4 jobs to all of the 4 tasks to all of the 4 workers. So first is the worker 1 will be assigned task 1, time would be 19. Worker 2 would be assigned. Okay, dear student, let's finish it up. So worker 2 is assigned the task 3 over here, you see, and the time the worker 2 is taking 16 minutes. So worker 3 is assigned task 2. Worker 3 is assigned task 2, 30. Worker 4 is not assigned to any task, since we took this as a dummy column, T4 as a dummy column. So T4 is whenever any task is assigned for a dummy column or dummy row, it means that worker is not assigned, that operator is not assigned, that professor is not assigned. Okay, let's sum it up. 19 plus 16 plus 30 is 65. So 65 hours is the least time these 3 tasks will be done by the 3 workers. Thank you very much.